Hey, and welcome to Alchemist Camp, where we learn Elixir by building things. And today we're going to build a game board. We're going to start with tic-tac-toe, but it's going to be pretty modular, and we'll be able to extend it to other games in the future. In the process, we're going to encounter Elixir's MapSets, the with syntax, which is pretty new as of Elixir 1.2 or 1.3, and we're also going to use structs and enforce keys and do a number of things that we haven't done in any previous videos. Also, if you're not coming from a language like Python or CoffeeScript, list comprehensions may be a new thing as well. So let's get started. I've already made a project. This is a new project made with mix new, so nothing you're missing here. I'm going to cd into it, and let's make another directory called Tictac, just like the project is as normal. And then inside of that, we'll make our square module, square.ex. Square, and at the very top, we're going to have enforce keys. This looks like any normal module attribute, but it's not. With enforce keys, any new square that's made must have the following keys, row and column. Def struct just says that it is a structure that has these keys, although it does not enforce it. Column and row, when the column is in the range of 1 to 3, and the row is in the range of 1 to 3. And we'll just return OK and a new square, row set to row, and column set to column. And now we need a function for when it doesn't match. It's going to be a one-liner, new, and we don't care what the row is, we don't care what the column is, because whatever they are, they're invalid. Because if they were valid, they would have matched the function header on line 5. And we'll return error and invalid square. And that's it for this module. Let's fire up IEX. IEX.bat, since I'm on Windows and using PowerShell. And -S mix will bring in everything from mix. An atom symbol, maybe row, column, line 2. Yep, I forgot an atom symbol. Okay, I'll try that again. Okay, so square, let's look at square. Let's look at square properly defined. Doesn't matter because it's still just any module name is just an atom as far as Elixir is concerned. Let's look at a new square. So, OK, my square equals square.new of 1 and 3, and inspect my square. And we can see this is a struct. Structs are maps with a struct key, and it doesn't implement too many protocols. Okay. Does not implement access behavior. All right, you have to use this one. So .call, .row, and this would be dangerous to do with a map if we didn't enforce the keys, but with a struct with enforced keys, we don't have to worry about trying to access an attribute that's not there. All right, and let's look at what happens when we try to make a new square that's out of range. 1 and 8, invalid square. And if we were to make a square without using the new function, just going on our own, and we didn't have the row and column attributes both, or didn't have both of those keys, then we get an argument error, and it's because we have this key required. And if we had anything that is not in the struct, such as height, then we get an error because height is not found in the keys. So these are the keys that it's expecting, and these are the keys that are required. All right, with that explained, let's go to our main module. And we'll make a squares function. This function will generate all the squares on our board. And we don't need any arguments to it. For column in 1, 2, 3, and row in 1, 2, 3, into MapSet.new square column C row R. There are probably some things in this that are new to you, so we'll just go over them one by one. So ranges are pretty much like ranges in Ruby or other programming languages. We'll inspect one. You can see it implements enumerable, so you can use anything like enum.count or enum.each or enum.map, any of those things you're used to. And you can also do comprehensions. So here's a simple one for C of 1 to 3, do C, and we get a list 1, 2, 3. But it doesn't have to be just exactly C. Like you could have C times C, and now you get 1, 4, 9. Or you could do a tuple of C times 10, and C times 100. And now we have 1, 10, 100, 2, 20, 200, 3, 30, 300. You can really do just about whatever you want with it. And the other thing that's really useful, and especially right now for our current situation, is if you have two different ranges in your for, then or in your comprehension, then you can use both of them in the do, and it will generate every combination of them. So say we do C plus R, it adds them up in every way you can. So you can see 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3, and so on. That's a little bit silly, but what we're going to do in our board is C comma R. And this basically just gives you all the possible coordinates for all the squares on our board. And we've also got into up here, which is like the enum into that we've seen elsewhere. And MapSet is new for us. So maps are key value pairs. Map sets are just sets of elements, and they're unique. So unlike a list where you can repeat the same thing multiple times, as we see here, in a map set, there can only be one of each thing. So if you have a set of 1, 2, and 3, and then you take the union of that set with 2, 3, and 4, you just have 1, 2, 3, 4. You don't repeat the 2 and the 3 because you can't have two items of it. And actually, let's just save this and reload the module. And now we can just say tic-tac-squares, and you can see the output. So it's a map set, and each item in it is a square, and we have all the possible squares because we generated the whole board. Next thing we want to do is we want to use these squares as keys to make a board, and it's going to be this kind of structure. We'll have a normal map, and a square here will be a key, and then the value will be empty. Oops, what am I missing? Oh, we don't need that. So the value will be empty until someone plays, and then the value will either be X or it'll be O. All right, let's implement that. So We're going to use a module attribute for players. X and O are the two players. Then we'll make a new board function like we saw in the terminal that makes a map out of all the squares. So new board, and we don't need either of those. And for every square S, we're using the function that we just defined below to make those squares, is into a map do S and empty. So we're making a list of key value pairs, each one being the square and empty, and then we're putting all of those into a map, just like we did with key value pairs into maps in our to-do list or some of the other apps we've made previously. Okay, we'll save that, have a look at it in IEX. Tic-tac, new board. Okay, so we can see this whole board, and is my square still defined? It is. So let's look at new board. Oops, that's not going to work. Let's define the board to be equals tic-tac dot new board. Okay, and my square. Okay, so look at board and the element my square, and it's empty. So that makes it really simple. And then we can do like a map update, like we could say board where my square is set to X, and we'll get a new board where it's set to X. So let's make functionality to play a turn. To make a play, we're going to need a few pieces of information. We're going to need the board, which comes in as input, and the column and the row where the play will happen, and then the player. The player is going to be X or O. So board, some location given by column and row, and then who's playing. And we're going to have to check all of those things. We'll have to check the player, make sure that it's a valid player. We'll have to check the location, make sure that's valid. And then we'll have to check that that valid location on the board isn't already occupied. And if all is good, then we play the piece there and we output a new board. I think check player is the simplest. So check player, and we'll use a case. Player do if it's X. Okay, comma player. If it's O, same thing. If it's anything but an X or an O, we return error invalid player. Okay, that's pretty straightforward. Oh, we need an end. Okay, place the piece. Place piece. And we need to know the board. I'm putting the board first because if we do any kind of chaining, the board is output after a successful play. So it's easiest if that's the first argument, so that we can just use a pipeline and have it go straight into the next thing. Place and player. And case board place. So this is doing a lookup on the square as we did in IEX a moment ago. If it's nil, that means there is no square on the board. Invalid location. If it's x, then we'll say invalid, actually we'll just say occupied, because if we look up what's in the board when we're about to play and something's already been played there, we can't play there again. Not in tic-tac-toe at least. And same rule if it's O. And finally, if it's empty, that's actually a successful play. And instead of error, we're going to return OK. And then we're going to update the board. And the way you update a map is by creating a new map, and that's because everything is immutable in Elixir. Place player and end the case. Okay, let's have a look at that in IEX. And let's import Tictac, just because we've got a lot of stuff to type. So we'll say game board equals new board. Excellent. Then player equals x, and square equals square.new of 3 and 2. Okay. Now, first we'll check the player. Next we'll place the piece. GB. Place is going to be square, and player is player. And we have a new board back. And we could pipe that straight into place piece again, and we've already got the board since that was piped in, and our new square will be, say, square column 1 row 1, and our player will be O. Access.get, oh, we had an OK. We'll say OK, game board now equals that. Game board and some other square. Okay, we get the idea. We are filling up the board with random plays. Okay, and let's try making it Z. There is no player Z. That's occupied. Okay, yeah, occupied gets checked first. Say we do that. But it didn't catch it here because we didn't go through check player. So you can see it's a little bit cumbersome to work with this in the terminal. But there's a really great syntax for dealing with these changed error and OK messages, and it's called with. So let's take a look at it. Make a new function called play at, and this is going to do the work of all three of these. We'll start with board because board is probably what we're going to be getting as output from a lot of other functions. And we want to be able to chain it in with pipeline syntax. Right, and we say with, and then what I'm typing right here is the response from the function I'm about to type on the right side. So with check player, we get a response of OK and player. If things went well, if they didn't, there'll be an error, and the error short circuits the with. It just ends it. And we're going to call this valid player, just to make it clear that it's not the same player that came in on the function. This is actually something that the with set up. And okay, actually okay and square coming from square.new with the column and the row. And I see a couple of problems here. We got to have column before row, since that's how everything else is in the program. And we also want a comma after each line in the with statement. New board that we generate from place piece at on the old board in the square that we just created from the column and the row, and the valid player that we checked in the first line. And at the end of the with, we have a do, and we're going to output OK and the new board. Actually, we're just going to output the new board. We can add the OK later if we extend the API further. So let's go over everything again from the top. So at the very beginning, we take in a board, a column, and a row, and a player as input. We check if the player is valid, and that has to be player because we don't have valid player yet. If it comes back as OK, we set valid player to be whatever this function output along with the OK. Then we go down to squared.new of the column and row that we got in as arguments. And if it's OK, it generates a new square. And then we place a piece on the board on this square and with this valid player. And finally, place a piece also will output OK and a new board. So we capture the board here and we respond with the new board. If any of these fail at any point, then instead of new board, we'll just get the error. So let's have a look at that in the console. We'll reload Tictac. Oh, we needed a comma there. Okay, and we'll re-import it. Okay, so do we still have the game board? We do have a game board. We'll just use this game board. We will pipe game board into play at 1, 1, and X. And that gets us an X in the output, but we haven't actually changed the value of game board. Now we have. And now we can't play there. It's occupied. And if we try to play 1, 4, we get an invalid square. If we try to play 1, 3, which is empty, with a T piece, we get invalid player. So we've got a pretty nice syntax here. We get error messages for whatever is wrong, and if all is right, then we just get a new board. So this is a pretty good spot to stop for today. We've covered quite a bit of new stuff in terms of language features. We've built out a pretty nice syntax, I think, for working with a board game. And even though tic-tac-toe is pretty simple, it would be a long video if we went on and continued the whole thing. So for tonight, if you want to reinforce this and learn some more, I've got some challenges for you as usual. I'll open this up with the Markdown previewer. So comprehensions can do all kinds of stuff that we didn't even scratch the surface of. So try doing number one, which you don't need to learn anything new for. Well, that was interesting. Don't need to learn anything new to do this. Just generate a deck of cards from lists of suits and ranks. So you have one list with all the ranks, like 1 through 9, and then Jack, Queen, King, Ace. And you'll have another list which will have hearts, spades, clubs, and diamonds, and use comprehensions to generate all the possible cards in the deck. Then number two is one of the things we didn't go over was that comprehensions can have restrictions in them. So this one is like what we saw before. We have for A from 1 to 10, B from 1 to 10, then A times B less than 10. So this will only match if A times B is less than 10. And the way list comprehensions work, if there's no match, it just gets thrown out. So this A times B minus 10 filters it down to just a list of A's and B's such that their product is under 10. Otherwise, we just have 100 numbers in the list because it's just like what we did with a board, except it'd be 1 to 10. So you can see here, this is the output from this comprehension. We have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so on up to 9. Then with the 2's, it stops at 2, 4, because 2 times 5 is not less than 10. It is 10. We go to 3's, and then that stops. You don't get to 3 times 4, and so on. So like that's kind of useful. You can use this for filtering files that you're getting out of a directory. Like you have a list of directories, run ls on all of them to get the files in those directories, and then filter based on something else. And it's a really compact syntax compared to what you'd see in the enum modules, for example. So last part of the challenge is check out this link here, elixir-lang.github.io/getting-started/comprehensions.html, and experiment. I'll put this link in the notes under the video. Do some stuff with binaries. Do some stuff with the file system. Mess around with it. It's hard to compare. I mean, there are a lot of things you can do with module structs too, but this is something that you will definitely encounter in other people's Elixir, and if you learn it well, it can simplify a lot of problems that would be kind of a pain otherwise. And with that advertisement for comprehensions out of the way, until next time, code on!